Good, Anish, can you hear me?
Yeah.
All right, cool. I'll still be a little bit slow today. Yeah? I'm recovering, but still not feeling very good. How about you today? Can you hear me?
Yeah, but you're very slow.
Um, can you hear me?
Yeah, better.
Okay, try. Okay, right, okay. So, did you read the pressure slide? Testing, can you hear me?
Yes.
All right. Did you read the pressure slide?
No, yeah, you said I have to read it by tomorrow, right?
I have to read them tomorrow. Tomorrow? No, I meant that you could start reading it this morning.
Oh, I did some math this morning, like Sec 3 math. Like the whole day I've just been doing Sec 3 math.
Sounds good. Ask me your questions on Sec 3 math first.
Oh no, I'm actually surprisingly decent at logarithms so far. I've been doing logarithms.
Okay. Right. Let me see. Since today is 1.5 hour, and you have been doing logarithm. Your Jamboard, I will put later 2 questions for you to discuss first, and then we'll try the reading before doing a function, right? Okay. So you sure? No other questions below?
Yes. Yeah.
All right. Okay. Then
I will read the slides by tomorrow for sure.
we'll start today. I'm curious about how far we can go with physics. Then we can plan better. Okay. This time, why don't you share your screen, and then I'll annotate on your screen. Right? You can also do that. So you open your slides, you share your screen, and then I can interact with that.
Okay, give me a second.
Sure.
Okay, can you see my screen?
Sorry, there was a. I cannot yet. You should share your screen.
I am.
Why can't I see?
Can you see?
Now I seem to be able to. Yes, right. So you're looking at the Jamboard. You're going to ignore that for now. But instead, you open the slides from yesterday, and then let's start from there today. Tell me if I'm too. Tell me if you cannot hear me. Okay.
Oh yeah, sure. Wait. Hold on.
Okay, yes, I can see the pressure, right? Okay, so you haven't read this at all, right?
Yeah.
Then I'll take charge of the tempo a little bit. So I'll be using my tempo instead. I want you to move to, I believe, page 5. Yeah, page 5, no, page 6. Okay, let's say page 6. Yeah, page 6. Okay. How much does this make sense to you? If it doesn't make sense, and when I say sense, I mean it doesn't connect. If it doesn't connect, you tell me. Okay, so what do you think about this slide?
No, I didn't get it.
Right. The slide's intention is clear, at least to me, right? If an engineer or a physics teacher, so I'm a physics teacher, your teacher is a physics teacher, he seems to think that the difference between force and pressure is important. I don't mean in terms of exam. I mean in terms of your own understanding and your feeling of it. Because, surprise, surprise, we can feel one of them. We have an inbuilt sensor all around our body to feel one of them, but not both, right? So which one can you feel? I don't mean your emotion. I mean with your physical body. Which one can you feel? Force or pressure?
Both.
Would you please explain what you mean then? How do you feel force physically and how do you feel pressure physically? This is important. I'm not asking this to test you. This is really important.
Force is a push or a pull force, so it's kind of self-explanatory. Pressure is, sorry?
You mean when somebody push you or pull you, you feel something?
Yeah.
And that's a force.
Yeah.
Okay, I can follow. How about pressure?
Pressure is force upon area, so it's also force, which is also again push or pull. Pressure is just the amount of force per given area.
That is correct. I will use an informal wording. Yeah, it's a concentration of force. So pressure is a concentration of force. It can be concentrated, it can be spread or diluted, right? So one more time. Are you sure you feel force, not pressure? That's how your sharing goes. You feel
yeah, okay,
force.
I do feel force. Pressure is like calculation.
Correct. You are, or rather, I agree with you, not your record. I agree with you in the sense that you seem to be calculating pressure in your brain, but the force we feel directly. Okay. In my understanding now, it is totally the opposite. I have to show this to you. If not, you will always be forever confused because you think what you feel is force and you calculate pressure. It's totally the other way around. I'm trying to prove it to you. Okay, I'm trying to do that right now. What am I supposed to do here? I'm supposed to okay, I'm starting my video. I cannot do that. Okay, there you go. Okay, I'm starting my video. Okay, so you can see my hand. Okay, you can see my hand, right? You can see my hand, correct?
Yeah.
I am pushing on my hand.
Okay.
I am also pushing on my hand. Very different, right? Very differently. I suppose I am good enough to exert the same pressure doing this and doing that. Okay, right? It's a very rough thing. Now I'm asking you to do it. You don't have to turn your video. First, do this. Please do that.
Okay.
Okay, you're doing that, right? Now you have a feeling, right? You have a feeling. Please notice that your hand feels more than your knuckle. Please notice. Your knuckle don't feel much. Your hand feels a lot. Your hinges lah. These are your hinges lah. What's the English word for this? Your joints. Your joints don't feel much. Your hand feels a lot. Okay, Ken? Now, this is weird, but that's how our body function. Weird because he is experiencing the same force as him. If I'm pushing you by 2 Newton, he is pushing him by 2 Newton. It's that simple. That one, can you accept first? That's one of the first things you learn in physics.
Yeah.
Okay, but the feeling is different, okay? So I'm primarily talking about the feeling in your hand because your hand is more sensitive than your knuckle. One more time, the front of your hand and especially your fingertip is much more sensitive to rather than the back of your hand. Your back of your hand doesn't feel much pain, right? If you want to slap somebody, I hope you will never need to do that. If you want to slap somebody and you don't want to feel hurt, you slap it with the back of your hand, right? You won't feel much. He will feel it a lot. Our face is also very sensitive, right? Okay, so back to this thing. Now, try doing this with, you try your best shot of the same force. Try this and try that. Okay. So how does it feel at the palm of your hand?
The one finger hurts more.
Not your finger, right? Not your finger. Your hand. Again, your hand is sensitive. Your finger is probably being numb, right? But mainly because no matter how small, your nail is giving all the punch, so to speak. I would argue you probably are not even giving the same force, but you're feeling much more. You're feeling much more than this. This is my first example of what do you feel here? You don't feel force. You feel pressure. You feel the concentration of force instead of force. If the force is very concentrated, you feel it more, regardless of whether the force is actually bigger or smaller.
Yeah.
If I put a nail, which is even worse in terms of area, it's smaller here, you just push a little bit, you will feel too much already, and you cannot continue with the force. Cannot. Not like this. Imagine if you punch a nail using your hand here, that will be the same force, and then you will experience or you feel much more. Your hand, which is a very sensitive area, feels pressure, not force. And your brain tries to calculate force based on pressure, not the other way around. Right? Let's try one more. Not sure whether you have this. Do you have a water bottle with a cap?
Kind of, yeah.
Is the cap rough?
Rough. No.
Yeah, not smooth. It's
no, okay, yeah, it is not smooth.
Right. So try screwing it very tight first, and try using your cloth to do so. It's because you will feel the hurt if you screw it tightly with your hand, such a rough bottle cap. So please screw it very tightly first. Again, with the protection of your clothing or something. You're done, tell me.
Yeah, I'm done.
Okay, now without the protection of anything, your skin will be touching the bottle cap, and you're going to try to open it. It's a very sensitive part. So try opening it.
Okay.
Right? Can you accept that your hand, which is holding the bottle, should be experiencing the same force as your hand, which is twisting the cap? They're both twisting. They should be experiencing the same force. They call it a twist force. I call it torque. But how does it feel? The hand holding your bottle compared to the hands, screwing the bottle cap. How does it feel?
Screwing feels like it has more force.
Yeah, which is not possible. They both have the same force.
Yeah.
You feel more because you're feeling pressure. Your sense, at least in your hand, I'm going to argue the whole body, but at our stage, it doesn't matter. Just your hand is enough. Your hand is enough to interact with the world, right? For now. Your hand is very good at sensing pressure, not force. Your brain do the calculation for the force. Why? This is not a physics question. It's not even probably a biological question. Why do you think our hand sense pressure, not force? That's a question, I guess.
Yeah.
The question I'm proposing is, why does our hand sense pressure, not force?
Oh, I thought you said our hands sense both pressure and force.
No.
It senses
only pressure, not force. Force is calculated in your brain. We learn by experience.
So pressure is like the application of force then.
I'm sorry, what?
So pressure is more like the application of force.
You mean force is more important than pressure?
And pressure can't happen without force, so yes.
Surprise, surprise. So again, surprise, surprise. That's because you learn force first. Everybody does that. People don't learn pressure first. That's a very unfortunate impact of the way we learn, right? The way we learn. The problem with that is there is no problem usually until you have to learn pressure, until you have to deal with pressure. And then every time you imagine something which is a force, your sense comes in and tells you that what is actually pressure is force. I find that to be disturbing when things get hard. So I'll try to tackle it from the start. I believe we sense pressure, not force, is because concentration of force, which is pressure, right? Concentration of force is more harmful than force. It is more important to know the concentration than the total force. To us, at least, to us. Not to everything in life, but to us, that takes precedence. The sensor for force and the sensor for pressure is different. Let's just say it's different. So in the interest of which one's more important, more practical in life, our sense is pressure. Now, I'm not doing a theory here. I am pretty convinced from practical life that concentration of force is more important than force. Do you agree or not? If you disagree, I'll give you more reasons.
Right.
Imagine that this is a nail, right? This is a very small amount of force. Imagine that this is a nail and this is my feet, right? Should I wait until the force is big so that I can react? Or should I begin to sense the concentration of force here and then make a reaction? Which one should I do? The force is very small. Yes, the force is very small, but the concentration is very big. If I could sense the concentration well, I will react before harm is done. Of course, sometimes we still kena, right? Sometimes we don't have time to react, right? But that is better than nothing.
Yeah.
The screwing is the same. It's just a simple act of opening a bottle cap. If you feel the pain, turns out that pain is pressure. Turns out, if you feel the pain, this is a different kind of pain, it's frictional pain, correct? If the pain is there, what would you do? You need to open this, you're very thirsty. What would you do? That's a question.
I would open it with a cloth.
Yes, you will protect yourself. Yeah. Your hand. Because your hand is important to protect.
Yeah.
You don't want it to get hurt. Once your hand gets hurt, a lot of things you cannot do, especially in modern life. Yeah, I'm not talking about making your hand super smooth. That one, you can choose to do that. Either way, protect your hands. Your fingers are more. Your finger is even more sensitive than your palm, unless unless you desensitize it, right? So sometimes if you do too much rough work, then our fingertip becomes less sensitive. Our fingertip is very sensitive compared to the middle side. This one also still sensitive still, but this one very sensitive. You can almost feel the difference when you run your finger through it. Try running your finger using the same force, and then you will feel that the tip feels more than the middle if you're still sensitive. Why the tip is very sensitive?
Because mine is sharp, I have nails.
Well, I suppose we don't hit the nail at the fingertip usually, I suppose, yeah. But we interact with a lot of things with our fingertip. It will be nice to feel more. So when you're sensitive, it means you feel more. What do you feel? Pressure. Like you feel the roughness, you feel the smoothness. You do a lot of things, a lot of feeling with your fingertip, right? So very increased sensitivity. This is using your body to explain that your body seems to prefer sensing force than pressure. I just said the wrong thing, at least to me.
No, I agree.
Your body seems to prefer sensing force than pressure.
I mean, if you're saying lesser pressure, then yeah, like the same amount of force and same amount of pressure.
You're saying that you can sense force and pressure. That's what you're saying, right?
Yeah.
We'll see. That is the struggle from the start. We'll see.
Okay.
My statement, or rather my stand is clear. We sense pressure and we calculate force with our brain. That means we approximate what the force is. We're very good at it. We are good. But we mainly sense pressure, right? Because pain is pressure. Right. Okay. So let me go back to this slide. Do we have to do anything with this? Oh, goodness me. I'll let your teacher explain this. I think. Okay, I'll make no comments. Right. So I'll let your teacher explain. I think he will be able to explain better. Okay. Next slide. Next slide will be 7. Same thing, right? So okay, right. Okay, right. I'll let your teacher explain that. Right. But I think we have the same thinking here. The difference between force and pressure is different.
Yeah.
The difference between pressure and force is important. I'm so sorry. Right. Okay. Right. But we may have different ideas about it. So let's see. Now for slide 8, I think you already know everything. So give it a try. Slide 8. Right. So big idea number 1, you okay?
Yeah.
Right. Big idea 2. This is a practical one, so maybe that's why they have those 2 slides.
Force is more relevant when a force affects the entire object. Yeah. All
right. So, all right. Okay. Now, in the end, pressure is a concentration of force, and it's force over area, right? Right?
Yeah.
Okay. So this is interesting. This is a very interesting question. What do you think the answer will be? A and B, both, right? Give me both the answer. You can do your calculation. You can do your calculator. Yeah, switch off my video. Correct. So you have an answer?
Yeah.
Right. So for both, yeah, give me, I have to write something first. How do I do that? Okay, I need you to allow me to annotate. So you are the one able to do that. So please allow me. Do you know how to do that?
Yeah, okay, I've done it.
Okay, let me see whether I can do that. Yeah, okay. Okay, I'm gonna write it down. So 8.
I don't see anything.
Oh, well, okay. For example, I'm writing. Okay, so I'm waiting for your answer.
Oh, okay, I can see. Wait, pressure. It is okay. So it'll be 300 divided by 4 times. A 37500 newtons for all the 4 legs. For B.
So 375. Tell me the unit.
Newton by meter square.
Okay, 37500, correct? Okay.
Yeah.
Okay, then all the 4 legs. Now 8.
It will be 9375.
93750, is it something like that?
No, no zero.
No zero. No, okay, sorry. Okay, so it's a smaller number lah. I think it's divided by 4, is it? Something like that?
No. 300. Sorry, 150000.
Oh, you times 4 now.
Yeah.
So 1500000. Oh, it was a nice number, right? So yeah. I'm guessing that a 150000, right? There's a 40, I believe, right?
Yep.
Okay, I believe that was from 330 times 10, right? That's a Newton, and then divided by 2 times 10 to the power minus 3, right?
Why do
this? Okay. I'm just finding out where the 1500 means. I think that makes a lot of sense. So it's 1.5 times 10 to the power 5 Newton per meter square. I think that's about right. So I can see why you get this number, right? You can see why. Now, this is your first challenge of the day. One of them is wrong. This is not based on answer key. I do not have the answer key. If I say that one of them is wrong, I have to explain to you. Before I do that, do you have some idea? Maybe I am right to say that you're wrong. Maybe, just maybe.
What is it? 600,000 for B.
You're saying that the B is bigger than the A. So let me check.
It doesn't make any sense.
Yeah. Because concentration of force, right? So concentration of force in the case of B is bigger than A. I already agree with you. That cannot be right. Cannot be right. Okay. Any other guesses before I try my best to give you a hint, and we'll figure it out together.
No, I don't have any other guess.
Right. Now 30 kg is kind of heavy. It must be a good table. Table these days maybe 10 kg huh? All right. Look at your table right now in front of you. Small or big?
Big.
All right, it's a big table, right? With stuff on top of it, right? Your laptop, your books and everything. Will it amount to 30 kg?
Yeah.
Okay. Now just imagine this. Then imagine the pain, yeah? I'm asking you to imagine the pain. You're gonna lift the table, 30 kg, quite heavy, more than half of your mass, right? You're gonna lift it up, okay? And then you're gonna squat while lifting it up, and then you're gonna put your hand on one of the leg, and then you're gonna slowly let go. No matter how slow, it will be painful. Yes?
Mm-hmm.
You are, or rather, are you sensing the pressure on one of the legs if you do that.
Where am I putting my hand?
Yeah, if you put your hand on, at the bottom of one of the legs, and then you let go.
I'm centering on one of the legs.
Yeah, just one hand on one leg. Just one hand on one leg. Is that 150,000? Is that 37,500? Which one? Your screen is gone.
Oh. Okay. Sorry, what are you saying?
Everything is gone again. So I'm going to write down again. Allow annotation again. Oh, no, I cannot read.
Okay.
The comma is to help us see. Yeah? Numbers are too big. Both the unit are the same. Your hand below one of the legs. Are you sensing 150,000? 150,000, yeah. Are you sensing 37,500? Are you sensing somewhere in between?
150,000.
Right. You're gonna now put, two of your hands and two of your legs under each table's leg. Don't know how you do that. Somebody's gonna help you to do that. Just imagine the pain, right? Done?
Okay.
What are you sensing? 150,000, 37,500?
More, right?
Sorry?
I'll be sensing more. More pressure.
You're already wrong. Your logic is blocking you right now. I'm serious. That is a common problem. You should be sensing less concentration of force. I would like to insist that you sense pressure. Now,
it will
video.
It will be 150,000.
Video. You see my video?
Yeah.
Like this. I sense more. Or here's 4. I don't know. Where's 4? Here's 4, right? 4 finger. I press very hard right now. I press very hard with 4 finger. And now I press very hard with
Mm-hmm.
Which one do you sense more? 4 finger or 1 finger? Which one?
I sense about the same.
You nonsense lah. Push as hard as possible. Push as hard as possible. Now I'm going to use as hard as possible. And now try as hard as possible. Feel properly, please. Feel your palm as hard as possible and your finger, oh my goodness, as hard as possible.
One finger does feel more.
Yeah. Let's be very clear about this. Feel a lot more or feel much more? Could you actually push as hard as possible before your palm kind of give up? Could you push that? Here's me pushing very hard here. 4 finger, right? I am pushing very hard. My hands are a little bit trembling because I'm pushing very hard. Before I reach that stage, my palm kind of give up a little bit before I can reach that stage.
Mm-hmm. I don't do
Oh my goodness. Right. Show me a video. You're a young person. Show me a video. We don't get this out of the way, then everything will be theoretical. If that is what you want in physics, we'll go that route. Oh my goodness, that route is very bumpy route. Four finger, your hand, as hard as possible.
Yeah.
That is totally blocked. Okay, thank you. Okay. Yeah, thank you. So show me your hand. Show me in a way I can see. So you make it more like vertical. You make it more vertical. Because if you're vertical and your hand vertical, then you can push harder for both. If you do like this. Vertical. You're doing jutsu with Naruto.
Yeah.
Do it as hard as possible. Top, but vertically. Vertical, yes, thank you very much. Yes, like that. Okay. So push as hard as possible.
Yeah.
Right. So you're feeling something with 4 finger, right? 4 finger.
Yeah.
Now push that hard until you're trembling with your one finger. Harder. I'm sorry?
The 4 fingers feel a lot harder.
Either you and I are designed differently or something is wrong with the demonstration. I'll try one more time. Let's do an impact instead of a push. An impact is much easier to actually gauge. So impact for 4 finger, go.
If anything, my one finger is the one that feels the pain.
Your finger is giving away.
Yeah.
So to speak. Your 4 finger is not.
Yeah.
So your one finger, okay, let me not concentrate on the palm or the finger. I guess same thing. My finger give away even though I'm supposed to give you the same force.
Okay.
My finger give away before the force reaches what I can do with 4 fingers. So my finger feels more, so to speak. My finger feels more and therefore decide to give away. Is that a good thing or bad thing?
A good thing.
If you decide to go through with your finger, even though you're feeling more, even though you know that's not the maximum force, and you decide to go through, your finger may break. Which one's better? Your finger sensing pressure or your finger sensing force? And then, telling you to give away.
Pressure.
So back to the table. You can imagine that you're a table, I don't know, right? So 4 and 1. Which one should you be feeling more? One hand or 4 hand?
One hand.
Because you are sensing pressure, which again I think is a good thing that we are built that way, right? Share screen, please. Right. So now back to the question, yeah. So the number seems correct, right? Based on our thought experiment, right? Correct what? 4 finger, I should feel less what? By 1/4 . If I have one hand or one finger, I should feel more. There, 150, 150,000, and 500. Why am I insisting that you're wrong, right? I agree with you on the experiment with our hands. Am I making a fool of you, right? What's going on? I still think that one of them is wrong. The reason is because the situation was never one hand and 4 hand. It was never like that for the floor. Is there ever the table standing on one leg only? Is there ever a scenario like that for the floor?
I actually have a table like that, but it always tilts.
I get it. Let's focus on the question. I get it. I get that part. Okay. My table is also like that. IKEA tables, right? IKEA tables.
There's another one, a smaller one.
A smaller one. I think the small one is slightly better, but the moment you go bigger, you're going to tilt sooner or later. Either table tilt or the leg tilt, right? Very annoying. Sometimes that happens with our plastic table in the school also, right? That happens all the time. In part A, though, is the table tilting?
Yes.
Are you sure? Table, question A, he's asking the scenario like this. One hand slightly longer, one leg slightly longer, so the one leg is touching the floor, and the rest are not touching the floor, the rest are flying. Is that the scenario of question A?
Yes.
Even though you can theoretically say that in the universe there is a table that can do one leg stand, I'll be very practical and say that's not the situation. I am interpreting the question. you are also interpreting the question. So this is your interpretation. And you're correct, we should be interpreting the question. I guess it's that deep. So another interpretation would be, this is situation A, right? Another interpretation to be, for both A and B, all four legs are actually touching the table. Touching the floor, what I'm talking about. All four legs of the table are touching the floor for both A and B. He's just asking for one and for all. What is he feeling for one leg, and what is all the other legs feeling? But I believe the scenario is everything, touches the floor like a property. Now, if your interpretation is A, this one, you are correct. Obviously, this and B is B. Obviously, A will feel more than B. Totally agree with you. I just so happen to think another interpretation, and therefore I think B is 37,500. Agree with you. A is also 37,500. Just a matter of interpretation. It's not that you are right or you're. It's not that I'm right or I'm wrong also. Everything depends on the interpretation. If you have no other question, I will leave it at that for you to think. This is already a very good question. Okay, we'll leave it like that. We'll continue to the next slide, if it's okay.
Wait, so what you're saying? Wait, so I don't get it. I don't get it.
Okay, I'll propose another scenario. Okay, I'll propose another scenario. Imagine I'm standing on one leg. Simple, right?
Yeah.
Imagine now I am standing on four legs. I'm crawling, just like my baby. So 4 leg versus 1 leg, right? Right. So I can do that, right? I can stand on my 1 leg quite easily. My baby still cannot do that. Right? Obviously, at my standing of 1 leg, I should feel more pressure. But the total force is the same, 4 leg and 1 leg. We will prefer to do 4 leg if we can. It's just not elegant, But when we were starting to walk, everybody crawl first, so to speak. I guess it's because it's less tiring to the muscle, right? Less pressure, so to speak. Something like that. Okay?
Yeah.
Okay. So back to this question. Is part A like me doing 1 leg stand? The table, is the table doing 1 leg stand? And B is the table doing crawling, like all tables should. Is it like that, the interpretation? The question did not make it too clear. Okay, I'm blaming the question. You have to interpret. Hiya, such a troublesome thing. So, Ainesh, what's your interpretation for A? Standing on 1 leg? The table. Imagine the table standing on 1 leg. So is that your interpretation? I'm asking you, I'm clear about my interpretation.
Okay, I can see that video.
Right. My interpretation is, in both scenarios, it's both 4 legs. Because the table is not me. The table cannot do what I can do. He just tried to confuse you with the question, is what I feel.
Okay.
This kind of thing, we can argue until cow come home. Right? Let's say your teacher do it another way, and she will have another interpretation to support that. I want to highlight the nature of physics question. Physics question are pretty much interpretation.
Okay.
Right? Not just the concept is important, the interpretation is also important. Okay, just want to say that. Right? Just want to say that. You will see this time and again. Right? If this happens in exam, I'm pretty sure more than half of the class will answer like you. and feel nothing about it during the exam? Pretty sure. Pretty sure. Because the interpretation seems to support the answer.
Yeah.
I demonstrate to you that this is not about right and wrong. This is about interpretation. Okay? Right. So whether I'm right or wrong, let's see lah. Let's see whether I'm making some sense or making nonsense lah. Okay, I'm going to clear the drawing. Okay, the drawing is not very important. Okay. Okay. Okay.
Yeah. Okay.
Okay. Moving on. Right. Slide 10. Don't have anything. Moving on. Do move on, Anish. Okay, let's see. And okay, we're switching tempo, we're switching scenario. This is harder to imagine. Which brings me to, I'm very happy that you swim. This is much easier if you swim. Okay. Right? We're switching from solid with solid, right? Solid object with solid object, earth, floor and table, you and your finger, you and the floor, solid and solid, to a solid interacting with liquid, right? They usually call gas fluid. So a solid interacting with fluid. Fluid is a very fancy word. It means both liquid and gas. Okay? Okay. So now let's move on to where I want to move on. Right. Let's move on to the next 2 slides. Okay, now here. So this formula, just tell me first, is this new or not new?
It is new.
All right. So I'm going to make it in a way that it does not seem new because it is not new. And then I'm going to quote your experience in swimming. This is one of the best experience to have a feel, right? So again, I'm annotating. I'm using the wrong pen. Remember that force pressure is the big formula is not this. The big formula is pressure equals to.
The big formula is pressure equals to MA.
Pressure is not equals to MA. That's just wrong, right? Pressure is not FA. Yeah, it's not.
No, pressure equals to Newton over meter squared.
Right, that's the unit. So it's F over A, right? Yeah. And I keep saying therefore, it's a concentration of force, right? So F over A, right? That's my left-hand side. Now, how about my right-hand side? My right-hand side, in this case, the force comes from weight of something above you. Obviously, if you have something above you, you will experience pressure or weight from that object, gravity, right? You're being crushed by it, weight over area, right? So far, so good.
Yeah.
You see the G and the G, that's a G, right? I want to focus on the M over A. So you know what's mass, right? You know that mass is right? Do you know that mass is volume times density? You should know this. You okay?
Yeah.
So I have the rho area. Here's my rho, which is density, and G. So I'm going to focus on V over A, rho G, right? Now, how did V over A, volume over area, becomes H? Any idea?
No.
All right. I'm using solid over solid, which is not the scenario here. So I'm using this first, solid over solid. So here's the floor, and here's the solid on top of the floor has weight, right? The weight is mg. The M is V rho. So this guy has volume, correct? And the area we talk about, let's be very clear, is the area down here, not the area here, correct?
Yeah.
So what is volume over this area?
Oh, it's pressure.
Volume over area is not pressure. That's force over area. Stop memorizing. It's concentration of force minus force over area. Yeah, you should understand it now. Volume over area is a very simple thing you learn in primary. Activate math, activate math. The volume of the cube over the, the surface area down there of the cube. Let's say, what do you have?
Height.
Yes, this guy, man. Because area times height is volume.
Yeah.
Because, right? So I hope the derivation seems to make some sense. I'm still not talking about liquid to solid lah. I should be talking about that after this. This is solid to solid first. Clear? I'm gonna clear my annotation. I'm gonna ask you to repeat that. Can you do it? Right. You can do it on the Jamboard lah. Okay.
Can try.
Can try. Right. So when you're ready, I'm gonna clear. Are you ready?
Sure.
Okay. Right. Go to the Jamboard. You start from the, you can do it there. It's okay. Start from the big guy. The big formula is pressure equals to concentration of force, right? What is that? Pressure equals to
F over A.
Yep. You start from there.
Okay.
Right. So this is always a starting point because no matter what, this is always correct. The concept of pressure is pretty simple. It's a concentration of force. But your target is this guy. How did, this guy become that guy? That's the question. No? Right. So please start.
So force is Newton, which is weight.
In this case, there's a weight of something above us, right? We are the floor, in this case. All right. So there's a weight over area. I guess that already makes some sense. If it doesn't make sense, you cannot derive this.
Yeah. Then weight equals to mgh.
Every weight is not mgh.
mg
over A. That one we know, right? We learned that very early, right? We got that. Okay, good. We are getting the G, right? Good news, right? We're getting the G, right? So
how do I get the P?
Must be from the M, right? You shouldn't be touching the G anymore. The G should be there. Must be from the M, right? It's not here. It's not here. I already erased it.
Yeah, my mouse is acting very weird. So bad. Okay. Anyways.
Well, it comes to, what is mass, right? What is mass? Mass can be broken down. Can be broken down. May I ask a question? What is rho? The guy in front is not P. It's not a small P. It's rho. It's a Greek letter to make it clear that it's not P. The guy in front. If you have no idea, you can switch back to the slide and check out who is rho. Rho is this guy. When I say rho, I mean this guy. Look. Right? Density of fluid, rho. It's not P, rho. Does mass have anything to do with density?
Yes.
Okay. Can you break down mass to something density?
Mass over area is density.
Mass over area is density. You're not making much sense. That's wrong, by the way. That's wrong. That's wrong. That's not density. That's not the concept that we have usually. Right? And if it is correct, you're still missing the H.
Density is volume over area. Yeah.
Density is not volume over area. That is also not making any sense. Stop memorizing.
Wait, what am I saying? Sorry, density is mass over volume.
Density is mass over volume. I hope that makes some sense. If it's not, then you have to memorize that. But if it makes sense to you, good for you. So can you break down mass? Considering that mass is, mass is whatever you say. All right. So do break it down, and we're getting closer to it, right? We are getting closer. Mass is not density over volume. That's wrong.
Density times volume.
Oh, it's times. Okay. I guess in times I agree, right? If it's times I agree.
Make it clear.
Okay.
How do I? What's going on?
Yeah, you have to do that first. Yeah. A bit weird, are we? No. You're right. You must click that arrow thing, and then you must double click the one double click. Then you can go in. No, that's the other text box that you need. You should delete that guy. Click the triple dot. Click the triple dot. Yeah. Okay. Got it. I did. Yeah. Okay. Okay. And then still have the G and have the A, right?
Yeah.
Would you please use the mouse, right?
The mouse is not working. What is going on?
I'm glad to say that the device I'm sending you will solve all these problems. So I'm gonna write for you because I'm assuming that you want to write this, right?
Yeah. Yeah.
Okay, then tell me what else you want to do. This is the row and this is the V, right? So notice that you have row and G already.
So then I have to try which one against area gets height.
Yeah, because the row and G should be just left there, like progress. So what about volume over A? How did it become height? Does that make sense?
Oh yeah.
It's math. Math, right? It's math. It was physics, and then math, right? So then rho GH, right? Okay, so you got it, lah. You got it. Okay.
Yeah.
Okay. I'm doing this. It's not that you will have to do this in exam, right? Some people lose interest at that point. Well, I guess some people's priorities like that, and I'm fine with that. But I'm doing this so that you feel it with yourself that this comes from that. It didn't come out of nowhere. There's a reason why they teach it second, something like that, right? But I'm not sure that your teacher will discuss the derivation. So I'm discussing it again, not so that you memorize, but so that, oh yeah, I did that once. So I'm not very afraid of rho GH, right? By the way, it's not the other way around. This is the main guy because it always works. This always works. This guy only works with fluid because the density here is the density of the fluid. Right? There is a reason why this only works for fluid and this only works for everybody. Right? If we ever need to go that deep, we'll find out soon. It depends on the question they ask you. In locals, we have to go that deep because the question demands that. Let's see what your question demands of you. Okay. Okay, so let's go back to the, the problem with me writing all this is that you don't have it in your Jamboard. Look. So if you want to keep this, you screenshot it right now and then you put it in the Jamboard before I erase it because I have to erase it. If not, we cannot move on.
Yeah, okay, but can I go get a new mouse first? Give me a second.
Sure thing.
Okay, I have a mouse.
Yeah. Okay, good.
I'll take a screenshot.
Okay. So once you done your, yeah, okay. And then I can erase it. Okay, I'm gonna erase it so that you can see it better, clear. Okay. Then
Yeah.
I think you have to clear your own writing also. Then they will make it easier.
Oh,
Right. Eraser, number two. Yeah. Yep. Use your mouse. Yeah, I'm pretty sure I want to send you the device now at this point.
yeah.
Pretty sure.
Okay.
All right. So again, let's move on to the slide. All right. So rho GH, right? So the H is the head of the fluid on top of you. That means you are submerged. You are submerged, then you feel pressure. If you're on top of the fluid, you don't feel pressure. This makes sense, right? If you're below the table, you feel it low. If you're above the table feels it low. The guy below feels it, right?
Mm-hmm.
Right.
Yeah.
Now, there is a big difference between how solid, like you pressuring the table or the table pressuring you. There's a big difference between that and you pressuring water or water pressuring you. For one, you cannot pressure water. Water give way to you. Correct? Every time you jump to the pool, the water is exerting some force to you. You feel some pressure, but it is totally not as hard as you jumping to concrete, which you will not do.
Mm-hmm. Okay.
Right? Especially if you dive properly. I can't really dive, my posture is bad. But when I dive properly, I don't feel much. If I dive improperly, I feel it because I put a lot of area to pop, something like that. Okay. So this fluid is the fluid weight above us. Your pool, how deep is it? Condo pools are usually not very deep.
1.2.
Oh, deeper than my pool. My pool is only 90 centimeter.
Oh,
okay.
wow. Okay.
Yeah, 90 centimeter and 1.2 is very big difference because I can't even practice basic water polo in a 90 centimeter pool. I can't.
Yeah.
Because water polo, it requires you to not to float, to wave your leg so that you float. I don't know how to explain it. It's called the egg beater. My leg keep hitting the floor. I wish I have your pool. I wish right.
Yeah.
So I do the next best thing. No, I just train my breathing by submerging to the deepest, but the deepest is only 90 centimeter. Okay, so 90 centimeter, I start my dive and I go from one end to the other. Right.
Mm-hmm.
Around halfway, I want you to imagine, because you're a swimmer, right? Along halfway, that 90 centimeter, I start to feel that I want to breathe, right?
Yeah.
Instead of emerging, I slowly go up and the pressure is lesser. Why is that?
Because then there's just
Lesser what? The physics student, lesser what on top of us?
water pressure, air pressure.
Yeah. So I'm tricking myself.
Yeah.
I'm tricking myself. I'm psychologically helping me to conserve because I feel more pressure at the start. So I calm myself so that I don't eat too much oxygen, so to speak. But when I can't take it, I go up a little bit naturally. It's just a natural thing. Oh, I feel less pressure. I can move on a little bit more. When I really cannot tahan, I will almost emerge, but I will not bob my head up. I will not take a breath. I'll maintain that until I hit the end. I trick myself, so to speak. Okay. Of course, when I'm almost emerging, I have almost no pressure on top of me, almost not. Right? So that I can swim my last leg before breathing at the end. Okay. Now you're a swimmer, so you should be able to imagine what I'm telling you, right? Mm-hmm. Where do you feel the pressure, when you want to breathe, where do you feel it?
On my chest mostly.
Why are you feeling it in your chest, not your leg, not your head, not your finger? I thought your finger is very sensitive, right? Why are you feeling it in your chest? It's inside, right? Not even outside,
Yeah.
If you're not panicking, you will sense that your body is not feeling much outside, the outside skin. The inside, totally different matter.
Mm-hmm.
Do you know why? Do you know why you feel it in your chest?
No.
Because the fluid, the water on top of you, right, pressuring your body is not very big pressure. It's reasonable, but therefore your body is pressuring your lung. What is the shape of your lung?
It's like an oval.
Kind of ish. What is the? I don't mean the shape. I'm wrong. Is it solid? Maybe that's why I should be asking. Is it solid?
Sure.
It is not. I mean, it is solid. It's empty solid.
Yeah.
Your lung is empty, not like your bone. Your bone is also, your bone have holes, but it's strong, right? Strong, solid. Your lung, no. So you feel it a lot in your lung. The water is pressuring your body. Your body don't feel it much. It's just normal. Your body is pressuring your lung. Your lung is empty. You feel it a lot there. That drives you to go up. Because again, your lung is empty. Your stomach a bit different. Your stomach is probably deeper, so it is less pressure. You notice that your lung is very close to your ribs, right? You do notice that? It's very close to the outer part of your body. Your stomach may be slightly better hidden. And it's usually full with solids, the thing you eat, usually. Your lung is full of gas. That's what you eat. Okay? So this pressure equals to rho GH. My point is this, you don't care about the G too much because why? G never changed in Earth, right? You don't care. You don't care about rho yet until we change fluid. But if you're swimming, you care mostly about height. If you are deeper, right, they call it depth. It's not height, actually, it's depth, right?
Mm-hmm.
When you are deeper, you feel more pressure. Correct, swimmer?
Yeah.
That's it, That's it. Okay?
Yeah. Okay.
We're going to move to the next slide using that simple thing. Just like how we use our palm and finger to understand that we sense pressure, we're going to use swimming to understand the next slide. And no, the next 3 slides. I think the third slide is the most important. So please move on. Page 15. This is just water. He's saying that the left-hand side will not happen on Earth and the right-hand side will happen. This has nothing to do with pressure, kind of ish. This just makes sense. Does it make sense to you?
Yeah.
All right. Now, jump quickly to 17. Jump quickly to 17. Look at that. These are two liquid, not mix, okay? They don't mix. They cannot mix to each other. They are liquids like that, right? Water don't mix with oil. Just consider methylated spirit as oil. Look at the height on the right and on the left. They are different. Oh goodness, this is 3. Oh my goodness, sorry. This is 3 liquid. Methylated spirit, water, and mercury. Goodness me. Look at this guy. The left and the right is different height. You go back to 15, you go back to 17, you go back to 15, you go back to 17. Is 17 messing with us? Look at 15, look at 17. Eh? Is 17 messing with you? Or is 15 somehow wrong? Is there any place on earth where, the left can be not the same as the right? We're talking about experience here. Considering your experience, is it possible or not? Now, page 16 is too liquid, so it's slightly less complicated than 17, I guess.
Yeah.
So is 16 and 17 messing with you?
Okay, I understand 17 Mercury, this whole A to B part applies slide 16, and this applies slide 16.
So you are sure that 16 is not messing with you?
Yeah.
16 is not, 17 is also not, but 15 is definitely correct. If one liquid, then it will be equal.
Yeah.
Right. Now let's go to 16. Let's go 16. I think your teacher is trying to give a good sense to you. 16, not 17. 16. 16, please. 16.
That's my internet. Okay, sorry.
16. 16, please. Thank you. Now, he's giving you a very good sense here. He tells you that oil is lesser in density than water. By the way, we may not think like that. We may think that water is higher density. Sorry, oil is higher density than water. I want to confirm this with you first. Our feeling is very important. Do you feel that oil is denser than water? Think about your experience with oil.
No, never.
Oil is less dense than water. You okay? You clear?
Yeah.
Okay. Then we're okay. Then you know that 1 liter of oil and 1 liter of water, do they have the same weight?
No.
Who is weightier?
Water is heavier.
All right. Okay. So now he's telling you that, the first picture on top is wrong. Second one, wrong. Third one, wrong. The only possible one is fourth. Very important. Very, very important. Do you understand? If you can understand this just like that, we're off to a good start.
No, I don't understand.
All right. Let's think about the first one first. The first and the fourth, right? Let's declare which one's first and which one's fourth. This is first. Oops. Right, that's first and fourth line. 2 and 3. Look at first and fourth. If fourth is correct, according to him, shouldn't the first one be correct also?
Yeah.
Okay. Then I will ask you to imagine this is something small. Okay, it's a lab apparatus. It's called a manometer. It's just it's just a tube connected U-tube. We don't use this in our day and time and age. Back then, this was a reasonably accurate way of measuring pressure, and that's why they keep using it. It's also kind of intuitive if you can get it. The problem is we don't see this often. Now, I'm asking you to imagine that this is super big instead of super small in your lab, so that therefore you can swim here. See, you're lying there very nicely. You're a good swimmer. You, for some reason, decide to plunge into the oil, boom, and then go into the separation between oil and water, holding your breath here and here. Okay.
Mm-hmm.
You tested out the first part A, and then you go to part B. Now, in part A, do you feel anything? I'm talking about your lung.
No.
Because?
Oh, okay, I understand. Because there is no water pressure
on top of you. You're normal breathing. But oil, even though lighter, should exert pressure on you, right?
Yeah.
Now, pressure does mean force. Although I keep telling pressure is different from force, but whenever there's pressure, there's force. That is something that you got it right. That one I can agree with you. So you're feeling here, I just say force because pressure. Here you're not feeling any force. How can that be? if there is a force here and there is no force here, it should push the water like that, correct? It should do that.
Oh, true.
Therefore, going to 4, if you're not swimming here, at exactly this line, I'm just following the line he draw for me, right? If you're swimming here and here, would you feel the same pressure?
Yes.
Because it implies you experience the same force. Because why? The area is the same. You notice that the area is the same, right? The pipe has the same area. So same area, same pressure, therefore same force. If this is same force, then this thing is correct. If you swim deeper here and deeper here, would you feel the same pressure?
Probably.
Heavier than the first one.
Yeah, but it should be the same.
Because you go down the same height or depth of water. Therefore, they are the same.
It all depends on whether, like, the amount of extra oil is the same as the amount of water.
Say it very clearly, the weight of the oil,
the weight of the extra
oil
balances out the weight of the water.
Yeah, at this line.
Yeah.
Right? You are correct. In this case, we are talking about the weight because we have been talking about the weight from the start, the weight above us, right? Look at 3 and look at 2. Now you should know that 3 and 2 cannot be correct.
Yeah.
It cannot balance that way. Now, if 3 happens, what will it be? Let's say I'm pouring water here. For a while, the water is higher. Just for a while. Then what will happen? This will push back into 4. Same thing with 2. When this happens, this will push back and become 4 also. Whereas in situation 1, it will push back to 4 also. Same thing, it will push back until it balances out. Okay?
Okay.
15 is not messing with you. 16 is not messing with you. You need to get this like almost immediately in all questions. It is assumed that you understand this. Don't memorize. Don't. If you want to memorize all the way. If you want to understand all the way. That's the way of physics. Any question first before you go to 17?
No.
Okay. Gonna clear my drawing. It's gonna right. So now you look at this. They purposely draw this line for you to help you. In exam, they may not. So I'm gonna take his help first. Analyze this line. You are swimming here, right? We always think of us swimming here, and swimming here. Methylated spirit is like just like oil because it's higher, right? Because it's higher. Does it make sense? What's happening here makes sense?
Yeah.
Does the mercury matter?
I mean, kind of, but like, because I mean, it's a constant, so no, not really.
So if you swim here, mercury is very dense, by the way. I think our oxygen will get squeezed out immediately if we swim in mercury. Plus, it's very toxic, so we shouldn't do that, right? We shouldn't do that. Oh, by the way, we cannot go into mercury because it's too dense. It will just push us up, right? Bala bala yada yada papaya. But if you can, theoretically, does it balance out? Does it balance out? Look at the height above you.
Yeah.
The height below you doesn't matter. The height above you balance out, right?
Yeah.
It's just additional mercury and additional mercury. Right?
Yeah, exactly. It does.
I am showing you not to be afraid of the guy below the line because the guy below the line never pressure you. But if you go down, then it will start to pressure you, but in the same way, left and right. So that's also okay. Okay. Now, they do a shortcut here. The pressure here is equal to the pressure here. I'm referring to your experience. What you feel is pressure, you interpret it as force. Your brain calculates force. It's pressure. You always feel pressure. So if you see this shortcut, I hope you can accept. However, if you do force equals to force, is it correct or not? If you do that, is it correct? Are you going to be penalized if you start with force equal force?
Oh, no.
Why not? You're right.
Yeah, exactly. I'm right.
Why not? But why are you right? You need to know.
What? I mean, what? Because
Main formula, please. Main formula. Main formula always applies.
Because it's
force equals to
pressure over area.
That's just wrong already lah. Pressure is the concentration of force. Remember that.
So pressure multiplied by area.
Remember what I say. Understanding. Pressure is concentration of force.
Yeah, so it's pressure multiplied by area. The area is constant, and so is the pressure.
Yeah. Because the area is the same in this case.
Yeah.
If the area is different, we know by experience that force the same doesn't mean pressure the same. 4 finger, 1 finger, remember? 1 leg, 4 leg. It's not always the case, In this case, the area is the same. So we can start with force or pressure. Don't memorize this. Understand it? Clear?
Yeah.
We'll probably go to 18 and then I think we should call it a day for physics. Let's go to 18. Oh, this thing. This thing is very easy, but you have to read it first. Now, please go 18, 19, and then 18, 19, all right, 20.
You don't have this.
Right. I do have, but I should be looking at it with you. Right, you share it by a copy, you copy it to me, something like that.
You can see.
I can. Yes, I can see. Now, I want you to read that.
Just to be sure.
Right.
Okay.
Yep. Now, I want you to simply read the remaining slide. Don't go to the new topic, right? No point. We should go to questions after this pressure, right? And the question I meant should be your question from your exam. Could you please open one of your year 4 exam and, let's just look at it together. What kind of pressure question would they give you, right? Year 4, I think. I think your year 4 will be very rough.
It's going to be a lot. Anyone who is studying in the holidays.
Pressure is supposed to be covered at the start of semester 2 of year 3. That's for the locals. Goodness me, right? MYE is okay. Right? Year 4 MYE is okay. Yeah, anything as long as you go to year 4. What's IP and OP?
OP is all up.
All right. Okay. That's it.
Which one?
Goodness, there's only 2. Okay, let's check. I don't know what paper 1 for you, so let's check.
This is 2020.
Is this MCQ? Oh yeah, so never mind MCQ. Let's go to the paper 2 first. Right? MCQ is difficult, but we'll go for the paper 2, right? So turning force, let's go. This is same as local, expected. Physics, you cannot change. Energy power. Oh, they tell you the topic. How nice, right? How very nice. Okay, let's go down.
They do actually. I think they just added this on later.
You're right. They might have added it after. Yeah. This is for learning. Okay, let's go down. Go down. Yeah. You're right. They shouldn't do that in exam. Okay, thermal property, never mind. Let's go. Because you're just going to find pressure, right? This is wave property, right? This is what we learn after this, right? Static electricity. Let's go down. That's DC. Yep. Yeah, going down. This is kinematics. Yeah, no. Yeah, this is very local. Reflection. No. You're gonna learn that later on. Electromagnetic is what you're gonna learn later on. Where is the pressure? My God. Let's go back to paper one. Okay, so the MCQ in local, they do it like in order of topic that you learn. They always do that. The MCQ in chemistry also. So this will be how you learn from year 3 to year 4. Measurement, right? Then unit, then go down. Then you start learning force, speed, this kind of stuff, right? There you go. I think 7 also pressure, I think. Let me see. Yeah, because they even say that. So 7, 8, obviously 8 is a very pressure setup, obviously. Then 9, okay, which is what you learned just now, but the gas of cylinder is not in your slide. Your slide is not complete, right? And then 10 is back to the kinetic energy, right? So 7, 8, 9. You are to read your remaining slide, and you're going to just try doing 7, 8, 9 for tomorrow. That will be your homework, okay? Then you can learn other things. Okay, right. Now, we have only 1 minute, so I'm going to try to do something new, okay? So look at your Jamboard. We're switching to math. We're switching to math. Oh, please write that down. 2 questions, 7, 8, 9, paper 1, 2020, year 4 IP. Paper 1.
Oh, sorry.
7 to 9, not 7 to 10. Oh, that's from him, sorry. That's from him. Right, so read the slide as much as possible. So tomorrow I expect honest questions from you. You thought about it and then you ask me questions. It's not me asking you questions. I asked you a lot of questions today, right? To help you think. Tomorrow, if you think about it, it's not going to be very easy. So ask me the honest questions. Okay. Now let's go back to Jamboard. We're switching to math. Page 1, you will notice that there's a logarithm question, right, for both. Now, maybe we'll just do 5 minutes of this. Short of doing it, we discuss this question.
Wait, what? There's no logarithm question.
There is. Look, question 9.
Oh, I
read question 9. I'm not asking you to do it. I'm asking you to read it and discuss with me whatever you want. You can make it bigger. Yes, please do make it bigger. Right. You can ask me anything. I will tell you what I can, short of doing it with you. You can write things, by the way. You can write things, just don't do it.
Okay, I'll be able to simplify the first equation.
In this one, right?
Yeah.
So you're not surprised that indice and log exist at the same question.
Oh yeah, I mean by logarithms, I meant I was doing indices and logarithms today morning.
Very good, very good. So you shouldn't be surprised. This is standard question in local. Right, you can simplify the first question, the first equation. Good for you.
The logarithm, the rule, right? In the brackets, if it's subtracting the brackets, does it mean outside? Like if you break it up, it will become divide?
No, you are flipping the rule and it is wrong.
Okay.
The rule is inside the bracket divide, then you can split it to negative outside.
Okay.
Right. Of course, you can reverse that. So the bracket inside the negative, you cannot do anything. Let me just state it clearly. Am I helping you doing it? Am I actually helping you to do?
Not yet. I mean, you cleared all my doubts.
Correct. We're just discussing simple log principles. Huh? That's what we're doing. Good.
Yeah.
So can you do something?
The first equation, I can get x equals to y plus 2.
Which seems to be a better equation than the original one, right?
Yeah, then the second one, I can substitute the x into y, get the quadratic.
I guess. But what do you do with the log? You still have to deal with the log.
Yeah, so then if it's minus, then it becomes divided, right? So then become logarithm 2, the quadratic divided by 11.
Okay.
Then the one can be log 2 to the power of 2.
Don't say to the power of, no, log 2 bracket 2.
Okay,
to the power
log
of
2 bracket 2.
To the power of
1.
Right. We're still not doing it. You're not touching anything. You're not writing on the screen. We're just analyzing the question.
Yeah.
Are you happy with your analysis?
Yes, and then after that, remove the logs and then simplify.
Right. Now, a very good reading is like this. We were reading just now, right? We're reading and everything. And then a good reading ends like this. Out of the 4 marks, how many marks can you get?
All 4.
Write it down. All 4.
Unless I can't simplify. Unless I can't simplify.
I know. But a good reading gives you the appropriate confidence. Right?
Yeah.
Let's see whether you can actually do the 4. Now, let's move on to the next question. It's slightly longer because it's a word problem. There's a part A, 1, 2, 3 lah. So all the question 4 lah. You should copy that. Just copy it. Same thing. Our target is to read until you can target properly. There's no rush in targeting. No. Use the next page. Use the next page. Don't do that. Use the next page.
We can also screen sharing. There's this big black icon.
You are screen sharing, what?
I am. I'll just stop screen sharing.
Okay, sure.
Thanks. Okay. And the number of people in the population.
First of all, why is this a logarithm question? Is it even a logarithm question? Why do am I fooling you? Am I confusing you?
Wait, does it say 0.85 to the power of n multiplied by n?
Small n times big N. I think they define both the small n and the big N. They are different stuff here. Because the question did say that what's big N and what's small n.
Why did they do that? Why couldn't they just use different letters?
I guess to annoy you, I guess. I'm serious. It is annoying. I'm with you this time. But what they cannot do is do small n, and define it differently. They cannot do that. Lah. Big and small still allowed. Still.
Okay. Then so n weeks is given by
What do you think? What question you want to ask? Can you get the 2 marks? Yada yada.
Power of n. Why is it to the power of n?
Yes, that's the question. That is the question. He's asking you that correct. Now, let's say time is short, okay? Let's say time is short. This is 2 marks. So you cannot get the 2 marks.
Yeah, I wouldn't be able
Does that mean that you cannot get the 3 marks below? Does that mean that?
I need to read that first. A vaccine was discovered after 30 weeks that could cure the people infected. No, I can just substitute everything in.
Oh, substitute where?
The 0.85 n.
Very good. So you know that you can use that in part B, part 2.
Yeah. So I'll get 3 out of 5.
So you get 3. There's one more part. Go to page 1. There's part 3. Maybe you can get that also. Maybe.
What is that? I can't read it.
Given the expressed as big N e to the power of k n. You can write down. Big N e k small n. Okay, right.
Okay.
Right. Ask questions. What do you think?
No, I don't understand.
Hey, let's say based on this reading, you get 4 plus 3, look, correct? Please write down 3 on part 2.
And 0 for both.
Yeah. Now, here's the rule. Let me repeat that. You have 10 minutes. You have 10 minutes to do as much as little as possible. But based on your reading, you're confident with 7, no? Right? So at least get the 7 lah. I believe after you getting the 7, you may still have time to think about part 1 and part 3 more. Maybe you'll get some insight after doing it. That usually happens lah. Doing it is also important. Reading is important, doing also important. Okay?
Okay.
Did we break the rule of, not doing this first?
No.
Right? I also agree with you. You can ask me more. Now, here's the next rule. Before the 10 minutes start, you should time yourself, right? 10 minutes lah. 10 minutes end, you stop, just like exam, right? Before the 10 minutes start, you can consult anything from your previous work. You just cannot consult when doing it in the 10 minutes. Okay, understand? When the 10 minutes starts, it's just like exam, you cannot consult anything lah.
Oh,
so
okay.
Before you press your 10 minutes, which you can start anytime you want, right? You consult anything now. You want to make sure that the logarithm is correct, the rule is correct. Okay, let me try that. What you cannot do when consulting is you look at the question. You cannot. If you look at the question, you're just reading it. You have to close the question and consult by yourself. That means you don't cheat lah. You don't like compare the question with the rule by looking at it. If you want, at least memorize it. At least put it in your mind before consulting it. You understand what I'm saying?
Yeah.
Right. If you have to consult this question 4, if you see a similar question back then, feel free to do so, right? Feel free to do so, but not side by side. Okay. Then you start the 10 minutes, then you stop after 10 minutes, and then we'll talk about it tomorrow. So you have 2 homework for physics and math.
Yeah.
I strongly suggest, this is a suggestion, not a rule, that you do this exam at 8 o'clock.
At what?
If you cannot, 8 o'clock in the morning, not in the evening. Either 8 or 11:30. You should know why I suggest that.
Yeah.
Right? Because that's just exam. You're supposed to perform them. So do it at 8 or at 11:30. The physics one, that's up to you. It's not exam.
Okay, sure.
Okay, you understand all the rule?
Yeah.
It makes sense?
Yeah.
Let's see whether it benefits you or not, this kind of training.
Okay.
Okay, then I will see you tomorrow.
I mean, it's good news. I do study in the mornings as well.
You mean at the 8 a.m. slot, kind of-ish?
Kind of. Yeah.
Yeah, well, that's a good start. I like the transition. I like the where you're going. I like it. I like this new Inesh.
Yeah, I study with my dad sometimes. Like I said, beside him, need help to concentrate.
Yeah. I get that. I don't think you can study by yourself. I get that.
Yeah,
I support that. I support that. If you're with other people, you seem to be okay. If you're alone, you're not okay. Again, don't stay alone, man. I can understand that.
Yeah.
Sounds good to me. I like all these things.
Yeah.
I think you're doing the right things.
Mm-hmm.
Okay. Now you may ask your father to time himself if you don't feel. Some people don't like to time themselves. I don't want to start the timer and then end the timer is very pressurizing. Okay. Then you ask your dad to just start the 10-minute timer and tell you when it's done. You can do that.
Yeah, sure.
Right? Okay. Anything. Just treat it as an individual. Okay. If there is nothing else, I'll see you tomorrow.
Okay, I'll see you tomorrow as well.
Bye.
Yeah.
Bye.
Bye. Have a good night.
Bye.